Good afternoon, everyone. Thank you all for joining today's Resideo webinar session where we're going to provide an overview of our thermostatic radiator valves. My name is Jamie Quanrud and I'm part of the Resideo sales training team. And on behalf of us on this call today, I'd like to welcome you to our training session. Before we get started with our overview, I'm going to cover just a few administrative items for everyone. Going forward, we are very excited to be offering our Resideo customer webinar series where we are giving you the opportunity to learn about our products. Go for a schedule of our upcoming webinars, please visit resideo.com/webinars for more information on these upcoming sessions. Additionally, we do record each of our sessions and you can find recordings of those sessions on this same website underneath the webinar recordings tab to reference at a later time. And then for those contractors who are joining us for today's live session and you are interested in earning one NAE continuing education credit, there are just a few things to note. If you provided your NATE ID on your registration form, we submit that information to NATE on your behalf for your attendance of today's live session, and we won't need any additional information from you at this time. However, if you did not provide us with your NATE ID on the registration form for today's webinar, and you would like to receive credit for attending today's live session, then go ahead and send us an email with your first name, your last name, your NATE ID, and the date of the session that you attended to homes.university@resideo.com within 1 week from today. We'll go ahead and submit this information to NATE 1 week following the close of today's session. Any requests that are sent outside of 1 week from this live training cannot be processed. And then also as a reminder, we can only process requests for NATE credits when you attend the live webinar sessions, and we are unable to process requests for watching a recorded version of any of our training sessions. If you'd like more information about the NATE program, please visit their website at www.natex.org. And then one quick note before we begin our technical presentation today. All of our attendees are muted. However, if at any point you do have questions during the technical presentation and you'd like to ask a question, please use the Q&A feature that is found in your Zoom webinar controls. We are reserving the last 10 to 15 minutes of our time today to answer any questions that you may have. So as we progress through the training today, make sure to ask those questions in that Q&A feature so that we can be prepared to answer those at the end of today's session. I'm going to turn things over now in the presentation to Chris Parks, who is one of our water sales leaders for the West Coast. And we're glad to have Chris here with us today to share his knowledge of our hydronic portfolio, specifically thermostatic radiator valves. Chris, we're going to hand things over to you for the technical presentation. Take it away.
Thanks, Jamie, and thanks to everybody that's attending today. We're going to cover radiator valves, not specifically thermostatic radiator valve, but we will spend a decent amount of time on that. But we're going to cover everything from the basics to options, applications, design considerations, as well as some mixing capabilities with thermostatic actuators. So I'm going to go ahead and dive right in. And of course, we're going to end every one of these with a Q&A session. So I'm going to dive right in and start explaining radiator valves. And for those of you that aren't aware, when you look at our hydronic product offering, we don't do the boilers, we don't do tubing or panel radiators or baseboard, but we do pretty much everything else in the middle. So from your mechanical room components to electronic controls to thermostatic to even radiator valves and actuators that we're going to be talking about today. So you can pretty much complete an entire mechanical room with our products. And if you have any additional questions around any of our other products, please don't hesitate to reach out to any of your local reps. And we are always happy to answer any of your questions. So jumping in today, we're going to talk about radiator valves. So when you look at radiator valves, I'm going to cover just the very basics to begin with, and then we're going to get more detailed as the presentation goes through. So if we're looking at just the basic question of what is a radiator valve? Simply put, it's a spring-loaded modulating valve. So it's got a little piston on there that opens or closes to allow water through. There's two different ways that you typically see these in the field. Either they come integral to some of the newer radiators, like our steel panel radiators that we see a lot today. Sometimes the valve itself is actually built into the product. And in that case, you would just add an actuator to it. But in a lot of the older cast iron radiators or even commercial fin tube baseboard applications, you install an external radiator valve. And I'm going to be going through all the different options, configurations, and styles a little bit more. Now, with our radiator valve, one of the nice things that we have is we actually have built-in flow limits. So if you look at it, essentially every one of our radiator valves includes a built-in circuit setter or balancing valve. And I'll talk about how that works a little later. So that's the gut. That's the valve itself. Is just a piston-operated modulating valve that's controlled by an actuator. So the actuator, we've got a lot of different types, but really all it does from a very basic standpoint is that actuator is going to open or close that piston, which is going to allow water to either get held up and not enter the radiator or continue on at a certain percentage of flow. So those actuators can be either manual, thermostatic, or even electronic. Typically, we see thermostatic and electronic actuators because those are what automatically control the radiator temperature. So it does it off the air temp around it. And we'll talk about actuators in more detail shortly. One of the questions before we dive in, I've done a previous training on zone and fan coil valves. And when we look at the US, that's probably the most predominant method where you use a standard thermostat that opens or closes a valve. And I wanted to just real briefly talk about the differences between a radiator valve and a zone valve, because I get these questions a decent amount. So when you look at it, the biggest thing to remember is with radiator valves, they're non-electric, meaning you don't have to run wires to them. So for retrofitting standpoints, et cetera, they're a great option because you don't have to worry about wireless technology, running wires into a building, et cetera. Whereas a zone or fan coil valve predominantly is going to require an external wiring, usually controlled by a thermostat. The control itself can be controlled with, when you're looking at a radiator valve, usually it's a thermostatic actuator, which is going to control that temperature, which again, on the zone valve, we're looking at typically a thermostat running it. When you get into what it can operate, we've got a few differences there as well. So zone valve, fan coil valve, it's typically either 2-pipe water or 2-pipe steam, and that's it. We have a very unique 1-pipe steam for some of those real old systems that are still around. We actually have a 1-pipe steam option for radiator valves. So we actually have some more application usages for radiator valve type configurations. And then again, one of the biggest parts, and I'll talk about this a lot when we start talking about design considerations, circulator placements, types, et cetera. A thermostatic radiator valve is modulating, whereas a zone or fan coil valve most times is just open or close. There are exceptions to that, but modulating valves allow you to build a much more efficient system as a whole, and I'll talk about that later as well. So getting into the meat of the presentation, I'm going to start with the valve bodies, so the actual radiator valves. There's several different types that we commonly sell. 3 different configurations I'm going to start with first. The first is your horizontal angle pattern. This is probably the most common radiator valve that we see. So if you have an old cast iron radiator with either a 1/2 inch or a 3/4 thread, this just screws in with a tailpiece right into the radiator. The pipe comes up from the floor, so it kind of goes through a 90-degree pattern. And then your operator, your actuator, just goes right on the side. And I've got application images to the left of that. That's probably the most predominant radiator valve that I see sold. So that's our horizontal angle pattern. And take note of these different pattern names because these will determine what type of actuator you need as I talk about actuators later. So horizontal angle pattern means the pipe comes up from the floor, 90 degrees into the radiator, and the actuator just bolts right to it. We also do have a standard angle pattern. Again, the piping on this predominantly comes in through the floor, 90s over into the device. Now, the one thing I will point out, if you see there in the application image, I'm using an operator that's actually mounted to the wall. And I'll talk about this more, but the reason is, if you look at how that operator is going to screw onto it, and when I'm saying operator, I mean actuator. If it screws on directly, you don't want to use a direct mount actuator. The reasoning is that heat, as it rises up, will play with the temperatures around it. It will not give you a real good accurate reading. So if you're going to bolt something directly to that actuator or bolt something directly to that valve, you need to get the actuator removed apart. But this is commonly used in fin tube applications, convector cabinets, that type of an application. And then we also have a straight pattern. This one I see done quite a bit as well. It's a little bit more of a retrofit, and where you typically use this is on a radiator that the piping is not coming from the floor. So let's say it's punching through the wall behind it, coming in through the side. If it comes straight into the radiator, makes it kind of easy to remember the name. If the pipe comes straight into the radiator, you're going to use a straight pattern. I see this a lot on retrofits where there maybe was no radiator valve control. So when the system just came on, it completely heated the entire radiator and then kept going. If you want to add temperature control, a lot of people cut these into the radiators. So this is another series. And then one of these, it's a little bit unique. If you'll notice those first three that I talked about, they all have very similar tail pieces. If you look at the threaded portion there, I can't remember if that's a 1/2 inch or 3/4 image, but they're all consistent. Those pipe sizes on the radiator valve bodies, they usually go from 1/2 inch up to 1.25 inches, depending on what series of valve body you're using. But if you look at that one pipe steam valve down below, it actually has a 3/8 inch thread. And the reasoning is, in one pipe steam, you're actually not going to tie this into the steam piping line. You're going to tie this into the air vent line. And I'll talk about why we do that and how that works. It's a little bit unique, different style valve, but essentially accomplishes the same thing that all of our other radiator valves do. I also want to talk about something unique when you're selecting your valve bodies. We make two different configurations. So the first, and when we ship these in through North America, we ship to both Canada and the US. And just looking at our sales history, typically the V2040, which I've deemed it our standard capacity, that's what gets sold in the United States. Our V110 is a high capacity. That's predominantly what's sold in Canada. And I'll talk about why that is. But I do want to point out we have two different series of valves. And if you look off the left and the right, we have two different actuators. So when you're selecting your valve body and your actuator, you must make sure you pair them properly. So we have standard capacity and high capacity. And what I'm going to do is I'm just going to pick one real fast and show you the major differences when you look at the flow capacity. If we pick our horizontal angle, and let's just pick a 3/4 inch size. If we look at our standard capacity, that valve is going to be capable of just shy of 64,000 BTUs per hour. 63,800 to be exact. Now that's with steam temperature. So if you're using water, it's going to be less than that. Whereas if we go to the V110, our high capacity series, it's more than double the capacity. So it can handle up to 162,000 BTUs per hour. If I break that into layman's terms, what that means is obviously your high capacity can handle more. But if you jump in and you look at, I'm going to figure an older house that has existing radiators, it can handle 35 BTUs per square foot is let's just say a typical load on an older house. If we assume on a water system that we're going to do a 20-degree temperature differential for flow, it means our standard capacity valve, in theory, with very high temperatures, could handle a floor square footage of roughly 1,800 square feet. Still a pretty large radiator, but keep in mind, the lower the temperature goes, the less that output's going to be. If we look at a high capacity series, to say our V110, that same 3/4 inch pipe going through that valve capacity has the capabilities of handling a 4,600 square foot area. So the reason I bring that up and the reason I say we sell a lot more of those in Canada is because of what the heating loads are. If you look at the majority of the US, even in cold climates, it's considered moderate to some of the areas I've been in Canada where you get much colder temperatures, negative 40 degrees Fahrenheit and Celsius. So we see a lot more V110 because the heating loads and demands are much larger. And a lot of times the radiators are sized with windows wide open, which may not be the case for existing buildings, but just something to keep in mind. We have two different sizes or configurations. We've got a standard capacity, high capacity. We also do offer our high capacity in an 1.25 inch pipe size. So if you run into some old radiators, very large radiators, we do have an 1.25 inch size, but only in the high capacity. And if you look at the little area I've got circled there in red, that's where the actuator bolts to. There's a very large difference in size between standard and high capacity. The reason I'm emphasizing that so much is because I've seen it a lot of times where somebody picks a valve out, gets the wrong actuator, and ends up having to swap them back out, and it just adds to the timing to get the project finished. The other thing I wanted to talk a little bit more on our steam radiator valve. This one's unique. So all of the valves I've showed you before can handle 2-pipe steam, but 1-pipe steam is a little different animal. It has to use the same piping for that condensate return. So with only 1 pipe going in, you're not able to just tie something directly to the piping for a thermostatic control. So what we've done is we've got an air vent, or a radiator valve with an air vent that essentially creates airlocks in the radiator to allow it to heat up or cool down. And what I wanted to do is just go through like a process with this, because 1-pipe steam is starting to become more and more of a lost art. So I just kind of wanted to walk through a quick process on what happens when you're using this style of radiator valve control. And I'm going to give just a situation. So let's say in our hypothetical situation, the boiler's turned off, which means there's 0 steam pressure on the system. The radiators are filled with air and the vent is wide open. So what happens now is as the actuator calls for heat, it begins to open that radiator valve. When some kind of an external controller, it could be a thermostat, a timer, whatever, when something external tells that boiler to turn on, the boiler cycles on and starts delivering steam to the system. It's going to go to all the radiators. Once the steam enters the radiator, it forces air through the open radiator valve and out through the air vent. Once the air is exhausted, the steam is then going to heat the thermostatic element of the vent and cause it to close. Once that steam cools, it forms condensation. That condensation is going to flow back out of the radiator through that same pipe that it came in on, and it makes room for more steam to enter. So it just kind of keeps happening over and over. Eventually, when you have an actuator on there that satisfies temperature, so a thermostatic actuator, it's going to close that radiator valve. Then what's going to happen is that air that's in the system begins to fill the radiator, and then that air prevents any more steam from coming in. It kind of acts like an airlock for those of you that are familiar with in-floor hydronic heating systems. So that radiator now becomes airlocked, which isn't going to let any more steam in sense, not letting any more temperature in. Once the boiler cycles off by an external control, thermostat, timer, etc., everything goes back to normal. The boiler comes off and that radiator is satisfied. So what it does is you still have to have an external control, but it allows you to provide individual temperature control to every single steam radiator. Assuming, this is the big assumption, that you can get the old 3/8 inch tapping or air vent out of there. If it's really old, sometimes that can be a little bit of a challenge. But as long as you can tie into that tapping, you can now add in retrofit temperature control to every single steam radiator. We've seen a lot of these. When I was on the distributor side of the industry, we sold a lot of these to really old hotels, schools, etc., that were just kind of running wild. So again, that external control would come on and every radiator would heat up. You'd have some rooms that were hot, some rooms that were cold. We sold a lot of these as really easy, great retrofits. So really cool product for 1-pipe steam systems. I did also want to talk about, I mentioned earlier that we've got essentially a circuit setter or a balancing valve built into every single valve that we sell. What I've done is I've taken a snapshot of one of our V2040 radiator valves. And if you'll look, we've got numbers 1 through 9 stamped on the cartridge itself. Now, when we ship these, we ship them wide open. But what you have the ability to do, and I'll tell you, most people don't do this, but you do have the ability to, you can actually self-balance every radiator that's being installed. Think of it like a high limit capacity. So what you're doing is you say, I don't want that valve to open any more than say 20, 30%. So what you can do is if you've got some small radiators, some large radiators, you can essentially die them all in. Now, I'll tell you from practical applications, if you're using an external control, it doesn't really matter because that actuator is going to modulate it open and close anyways, based on what the temperature around it, the air temperature is doing. But if you do want to dial one in, let's say you put radiator valves on and you have manual on-off actuators, you could go through and actually self-balance the system by essentially restricting the flow. So there's some instructions in our installation manuals on how to do that. Basically, you grab a crescent wrench, you tighten it all the way down, and you mark where that little hash mark is with like a marker. So it shows you where the completely closed position is. And then you start turning them counterclockwise so that you get your proportion opening. So you've got a setting from 1 through 9, and each one of those gives you a different CV rating on the valve. Again, most people don't do this because most jobs that I see, and when I say most, 97% of the time, you're using some kind of a thermostatic or electronic actuator, which is going to essentially open and close the valve for you. But we do have the capabilities of doing this right there in the valve. I also get asked a lot, well, what happens if I need to service the valve? If you're looking to service the valve, we actually make it really easy. We've got a valve service tool, and we've got some part numbers. We can provide that to you if you want to source them. But really what it does is it allows you to service it without having to drain anything down, which I've been to a lot of job sites. That's a big deal. So this service tool bolts on to the valve body after you take the actuator off, and will actually unthread the cartridge, allow you to start pulling it out and isolate it so you keep the system under pressure and you can pull that cartridge out. That allows you to get in and clean the cartridge, check it for proper operation. You can replace it without ever having to drain the system down. So I think this is a very simple yet pretty ingenious product. And you know, the only thing I will point out is if you've got a cartridge that's been in there for 20, 30 years, don't use this on it. You know, it's kind of like don't use a torque wrench on something that's seized up. You want to use a standard wrench just to loosen it. So, you know, step one, and I'll highlight this because you could break the cartridge removal tool if you don't. Step one is just to go in and kind of take a breaker bar essentially and loosen that cartridge. I think it's a 19mm socket. So just get in, kind of loosen it a little bit, then put that cartridge removal tool on, and it'll allow you, follow the steps in the install manual. It'll allow you to completely remove and reinsert the valve cartridge without ever having to drain the system down, either water or steam. Now, we talked a lot about valve bodies. I'm going to talk even longer about valve actuators because this is what really gives that valve the magic. There's 3 different types, as I had mentioned. The first is a manual radiator valve. You see an image there. I don't see a lot of these. All of our valves that if you buy a radiator valve from us, it's going to come with a manual handle on it. What most people do is just use that for initial setup to make sure it's working. But you can actually open or close it. Usually the only place I see this installed in a permanent application is on towel warmers. Towel warmers are a little bit unique. It's basically a radiator that you set your towels on, for those of you that don't do a lot of them. And you can tie it in with an in-floor loop. You can do a lot of things with it, but you usually don't want to control it with a thermostatic head like you would a radiator that's heating a room. And the reasoning is, more times than not, it's covered up with a towel. So the whole purpose is just to deliver hot water through that towel warmer so that your towels are nice and warm, they dry faster, feels good when you get out of the shower. So manual radiator valves, usually I just see them on those applications where you want to either unscrew it to open it and make it hot and screw it down to close it. Most of the time when we're looking at radiator valves and using either fin tube or convectors or actual radiators, we see a thermostatic radiator valve. And we got a lot of different configurations I'm going to talk on. I'm showing just the real basic direct mount that screws right to it. But it's automatic. So what it does is it's going to sense all the air temperature around that actuator. As it gets hot or cold, it's going to operate just like our thermostats do. And it's going to open or close that piston on the valve body to allow water to go through it. Very basic. Typically, they're stamped somewhere between 1 and 6. And all that means is think of it like a comfort control. 6 is nice and warm, 1 is nice and cool. So there's no digital readout. It's just a simple twist it to a number that feels comfortable and leave it alone. When you get into an electronic radiator valve, these are pretty nice because they give you the ability to, now you can do programmability. So you can actually go in and say, well, I'm going to be gone during the day, so I don't really need to heat the radiator. You can actually bring the temperature down. You can see the actual temperature right there on the valve or on the actuator itself. And it can be programmed with a lot of different things. So I'll talk a little bit about that, but I look at that as an upgrade to the thermostatic. It's electronic, but it uses batteries, so you're still not wiring anything in. But it's I say that it's the equivalent of going from, a real basic thermostat to a digital programmable thermostat in the HVAC world. So pretty neat. Still does the same thing, goes on the same valve body, and screws right on and operates that valve. When we look at our different configurations and I'm looking right now at thermostatic valve actuators. Again, I've got 2 different columns here because, again, we have 2 different series of valves. And if you'll see on the right-hand side where I'm showing images of all the different actuators, or sometimes they're called controllers, you'll see I got 2 different part numbers. And the reasoning is, again, the different part numbers fit the different types of valves. So just, again, as an asterisk, I'll tell you, this gets messed up a lot. So just pay attention to that. But our direct mount operator just screws right onto the radiator valve body. So this will just bolt directly to that radiator valve. When you get down here, these are very common as well, especially in areas where maybe you have the radiator right under the window and there's drapery over top. The problem is if you have a curtain over top of your direct mount, it's not going to be able to sense the air temperature, because essentially what you're doing is overheating it. It's just like in a thermostat. You always want to make sure that you put the thermostat in a neutral spot. So you don't want to put it next to a fireplace. You don't want to put it in an area where sunlight is going to hit it, because it'll give a false reading and it'll never heat the room up properly. Well, it's the same thing with radiator actuators. So if you're looking at direct mount, you need to make sure that these things can breathe. If you put a curtain over them, if they're getting direct sunlight, if they're right next to a fireplace, they're not going to give the proper temperature back. So what we do is we move into a wall mount. So if you've got an instance where you can't make that work, we can get into a wall mount operator. So very basic. What's going to happen is this piece here is actually going to thread onto the radiator valve. It then is going to use a capillary tube, which is just a gas-filled line that goes into the wall mount actuator where you can do your comfort settings. So just like on the radiator valve where these are marked 1 through 6, this is also just going to have a numbering system. So essentially it's kind of dial your comfort in. But what's happening is you're mounting the operator, the sensing is being done here, but then it's using a capillary tube to go down to the operator to open and close the valve body. Very similar to how our aquastats work if you use one with a remote sensor. The other thing I do want to point out with the capillary tubes, these cannot be cut or shortened. That I see that happen in the field from now and then. These are gas-filled lines. If you cut them, you've essentially broken it. So you can't put these things back together. So never fold these, never fold them in half, kink them. You always need to leave them kind of loose because you need the ability. Think of this like a real small tube. You need the ability for this to remain consistent and filled from the factory. So we've got wall mount. Because of that, we have wall mount operators with 2 different capillary lengths. So when it says 6.5 foot or 16 feet, all that's doing is referencing the amount of line that you have available here. So most of the time, 6.5 is plenty long enough to get it away from whatever might be blocking the direct line. But every now and then you might have to wrap it around a corner. So we've got a longer version available. Now we do run into some other unique applications here. We have a wall mount with a remote sensor. And I'm an illustrative guy. What I'm going to do is I have some other drawings that will make more sense of these next 2 products. But basically the wall mount with remote sensor, what you're doing now is you're putting the operator up on a wall. You're putting the actual device on the valve body, and you're using this to do all the sensor or the temperature sensing. So we see these a lot in large convectors, to where maybe you want to sense the temperature inside a cabinet and just have this out. Maybe it gets covered, maybe it's in a case, etc. So think a commercial application where they don't want the manager or employees tampering with temperatures. You can put this up, put this inside the cabinet, and then actually have this do the operation. And then last but not least, we've got another series that is a direct mount with remote sensor. So let's say you want to direct mount something, but that's not where you want it to do the temperature reading. Let's just say it's there. You want to leave it standard look, something like the direct mount, but it's not in the right spot, it gets covered up, etc. Or again, you don't want anybody tampering with it. You can run a remote sensor and get the sensor out of the way. So lots of different ways to make these work, set them up, put them around. And I've got some images that show different application usages for each of these. But again, I do want to point out different part numbers for the different series of valves. So again, reemphasize that over and over again. And this is the majority of our thermostatic offering. So again, non-electric, you just put it in, it just takes care of itself. Going into the electronic, again, I want to say think of this as an upgrade to your basic. I've got a lot of jobs that we used to sell these on for commercial remodels. So we saw a lot of hotels that people didn't understand. This type of actuator is very common in Europe, but in North America, a lot of people don't know what to do when they see something that says 1 to 6. So what we have done is we've offered these on a lot of jobs that are commercial. Say, again, hotels are a perfect example, old hotels that have standard radiators, because what you can do is you can now give that person a temperature dial and control to what they're used to seeing. It also, by making it electronic, we can add some extra technology into it. So not only is it programmable, but we can do temperature limits and stops. It's got some functionality in, so if it sees an extreme temperature change, it's not going to react instantly to that. We can do freeze protection. And since it's operating off a battery, we got a low battery indicator. So it lets you know when it's time to change it from a maintenance standpoint. And the analogy, as I had mentioned earlier, that I continue to give with these is think of upgrading from a thermostat in your wall that just has a low to high to a programmable thermostat. This is what you see in almost every single home today, whether it be programmable or even just a basic digital. This is kind of the world that we live in today. So this is the migration that we're starting to see on the radiators now. So whereas everybody for the last 100 years used to see just a basic 1 to 6, we're starting to see more of a migration into digital. People like to see the temperature. They're used to seeing it. Everybody's got a phone and a camera in their pocket essentially now. So this is just an evolution of the basic radiator valve that's been around for a long time. It's a neat offering if you're looking especially at doing upgrades. And from a configuration standpoint, I just briefly wanted to show how it hooks up. Very similar to our standard radiator valves, our thermostatic valves. What you're going to do is there's a little adapter that screws onto the valve body, and then this just pops right onto this. And again, as the temperature heats up and cools down, there's a little motor inside of here, as opposed to on the thermostatic piece, it uses wax or oil to control bellows. With this, there is an actual motor that's going to depress that piston to allow water to come in and out. So very nice, easy. There's a couple of batteries inside of here. Again, the install manual walks you through all of it. And since a lot of the places that we've been selling these are in commercial applications, I also wanted to bring up the point that this is tamper resistant. Anytime there's batteries involved, etc., you want to make sure that nobody can just walk up and take them out. So we do have the ability, there's a screw when you take some of the covers off that you can put right into there to essentially lock everything together. So for commercial applications, this is a really big deal. And again, since most of the applications I see these on are commercial type applications, I did just want to point that out briefly. Now, as I had mentioned, I'm a visual person, so this helps me a lot when I'm looking at what actuator do I need, what valve body do I need. We have in our install manual, and I'm not going to go through all these, I'm going to highlight a couple, but in our install manual, you can pull them up. So I use it a lot like a cheat sheet because you can literally walk into a radiator and see how you're going to be installing it and use our charts that we have to determine what valve body configuration you need and what actuator style you need. So again, I've already shown a few of these, but you know, a couple different direct mount styles. So if the pipe's coming from one direction straight into it, here's this configuration. So this is a straight pattern with a direct mount operator. Here's a 90-degree with a direct mount. And again, the one thing that you do not want to do, if you look here in figure 13, if you look here, you never want to mount your operator vertical. If your actuator's vertical, the heat is going to rise up because we're using very convective heat with this. It's going to rise up and it's not going to give you the correct reading here. So if you'll look, here's one that maybe there was no other option. Maybe this is what was here. So we have an operator, an actuator that's using a remote sensing element. So they've taken it through a capillary tube and put that remote sensor external to the operator. Because if this was just direct mount, this would give you false readings. So this is a no-go on figure 13 with standard direct mount operators. Talking about the drapery that I had mentioned in figure 15, if you have window curtains, drapes, etc., that are over top of the operator, it's basically going to bake it. So if you've ever done that before, been up to a job that's got a radiator with curtains over it, it is incredibly hot behind there. So this gives you the ability to run a sensor out. Or if you look up here in figure 17, you could actually, instead of running a sensor, you could actually put the wall control right here. So lots of different options. And here's one with that, you know, dual where you've got the operator and the sensor. This is a commercial job where maybe they don't want anybody to have access to it and they want the maintenance person to change the temperatures. But again, our install manuals have a lot of these different images relating to what type of actuator valve and body you want to use. So these are at your disposal on our websites. And then getting into kind of stepping out of the particulars and getting into the design consideration. One of the things I wanted to point out is over the last 5 to 10 years, we have seen a big migration from fixed speed circulators to variable speed circulators. And there's several different types. So I'm going to give everybody here on the call a little teaser. We actually have a variable speed pump line coming out in March. So I do want to emphasize this is a perfect application for variable speed. So as I had mentioned, the radiator valves are modulating, meaning as that operator heats up, the air temperature around it heats up or cools down, it's going to move that piston a certain percentage to allow variable flow to obtain the correct temperature through the radiator. So when you're looking at variable speed circulators, I'll speak to ours, uses a pressure differential. So as it sees pressures change inside the system, in other words, one valve opening 10%, another one opening 30%, it will adapt to fit the proper flow rates based on changing pressures in the system. This is much more prevalent than, say, an on-off zone valve system, because 6 on-off zone valves are going to give you proportional rates within those 6, but this one, ever-changing pressures in the system. And when we look at our systems, these are newer style radiators, panel radiators, where maybe the valve is built in and we're using operators, so just the actuators on the outside. I get asked a lot of times, well, how do you control a system like that? Since they're non-electric, you know, if we're looking at our zone valves, we typically see zone valves having a wire that goes back to the boiler to tell it to come on. Well, in these systems, there is no wires that go back to the boiler. So how do you make it come on and off? Well, there's a couple options for that. What I see most commonly is just a single thermostat. So let's say it's a one-story system or a two-story system. What you're going to do is you're going to put that thermostat somewhere in the living space, and it's going to turn the entire system on and off. Think of that as like your master on-off thermostat. But then what's going to happen is with our thermostatic radiator valves, every single radiator is going to be its own temperature control. So if you're using standard thermostatic actuators, you're going to have that number 1 through 6. Or if you use electronic, it looks like a digital thermostat. So what you need is you need some kind of a thermostat to tell the entire system to come on or off. And then every thermostat in the rooms is going to modulate on its own based on its own temperature control. So I see this as personally the best option. So just one thermostat that turns the boiler on and off, and then these will open or close individually as they need to. I have seen Another option, which is running constant circulation on the boiler, utilizing nothing but outdoor reset and warm weather shutdown. Some boilers can do that effectively. Some boilers cannot. I'm not going to go into the details on that, but essentially the way it works is your boiler's got an outdoor sensor. It's reading the temperature outside. It's constantly running to maintain temperature. And if it gets warm enough outside, it shuts it off. Again, some boilers do great at that. Other boilers, it's not a good idea. So check with your boiler manufacturer of choice to see if they suggest using constant circulation or if they don't. Because in that application, there's no need to run an external control because that boiler is essentially already primed and ready to go. The other thing I'll bring up is we get the call a lot, since again, we do a lot of the mechanical room valves. Well, I've got an old radiator system, but the homeowners hate it because those radiators get way too hot. Well, there's a couple different options. Essentially, the only way you can fix that is to bring the system temperature down. Because with our actuators, our radiator valves, all it's doing is controlling the flow of either water or steam in and out of the radiator. So if the water is coming in, and this doesn't really work for steam system, this is water only, I should emphasize. But if your water's coming in at 180 degrees, it doesn't matter if it's coming in slowly or quickly, it's still 180 degree water. So what you can do is add a mixing device. And what that mixing device is going to do is allow you to temper the water down to something that's comfortable. So I've got, my child's a 1.5-year-old, and we have tried to baby proof the house the best we can. And I'll tell you, if I had a radiator that was being fed 180 degrees, I would freak out. So what this allows you to do is temper the water, bring it down to say 140 degrees, 130 degrees. And what it'll do is it will lower the water temperature going to the radiator, which in essence means it's not going to get as hot. A couple of things I'll point out. You need to be very careful that the radiator can deliver enough output at lower water temperatures. Because the lower the water you deliver to a radiator, the less output it's going to be capable of. And there's a lot of charts. If you pull up any radiator valve or any radiator company of choice, it's going to give you a chart that says, okay, our radiator is rated at 1,000 BTUs. However, that's at 180 degrees. So if you only feed it 140 degrees, maybe you're only going to get 700 BTUs out of it. So check your radiator. There's some resources out on the internet for checking old steam style radiators, old cast iron, but most modern radiators today, if you're doing a new install, will show you what the outputs will be at varying water temperatures. We do have a really nice mixing valve that a lot of people have never seen before. And the reason I like this is it's a great option for a low cost solution that works very well in radiant heating applications. And what it does is, the reason I'm emphasizing this is because it ties into what we've been talking about during this presentation. It uses a thermostatic actuator. If you'll look there at the operator I have, it's basically the same thing that you've seen slapped on the radiators. But it uses a 3-way valve that has a piston style device that's going to modulate that valve based on what that sensor is going to read. So you take off that little white cap on the valve body. So get my mouse, this cap comes off. You thread the actuator onto it, and you take this capillary device and you're going to strap it to the outlet. It's going to modulate the valve here to deliver the temperature right here. So when you're dialing 1 through 7, you're essentially setting the temperature that you want this outlet pipe on the mixing valve to be. The reason I like that is because I see a lot of people using thermostatic mixing valves as inexpensive ways of doing it. And the problem is they work okay in high mass systems, but in low mass systems like our radiators that don't have as much water, these valves have a bad tendency of hunting if you don't have proper design, which means you've got correct flow, you've got the correct temperature differential from hot and cold. If these aren't met, the valve will hunt. So you're not going to get a very consistent temperature coming through here. That's why I like this, that hunting goes away. You hook it up, you use the sensor, it is going to modulate the piston to give the proper temperature here. So I really like these for simple, inexpensive 3-way operation. If you wanted to get into the cat's meow, not exactly what we were talking about today, but We do offer electronic as well. The advantage of going electronic is that now you can provide a varying temperature. So whereas these first two options are set and forget. So let's say you want the radiators to be 140, the radiators are going to be 140. If you go to electronic, you can actually vary that on the outdoor temp. So if you've got an old cast iron radiator or a cast iron boiler with radiators, you can actually put a sensor, use this control, or T775 control. And what it'll do is, through the way of a modulating actuator, it will actually vary the temperature. So if it's really cold outside, maybe it sends 150 degrees to the radiator. If it starts to warm up, maybe it's only going to send 95 to 100 degrees to the radiator. So this is a nice option, higher end, costs a lot more money, takes more time to program, but really what I wanted to emphasize is we have a good, better, best solution for your systems, depending, because a lot of hydronic jobs are custom, and I know that you as contractors have to kind of vary your quotes based on the needs of the homeowner. So with that, I'm going to pass it back over to Jamie, and we will get to our question and answer section in just a moment.
Great. Thanks so much, Chris, for walking us through the overview of our radiator valves. If you're interested in finding out more information on the products that Chris covered during our session today, make sure that you visit our new website at www.resideo.com/pro. That's shown here on the screen. There's lots of great features and information on this site that can give you more information on all of our water solutions. So please be sure to refer back to that new Resideo Pro website for more information. And as Chris mentioned, we are going to transition to answering some common questions about a lot of the products that Chris covered in our session today. And we're going to have Michael Ortiz join us to help Chris answer some of those questions. Mike is also part of our water sales team as well. And then just a quick reminder, if you do have questions on any of the products that were reviewed today, make sure that you take a few moments to enter that information into the Q&A feature in your Zoom controls, and we'll do our best to answer those questions in the time that we have remaining. So gentlemen, I'll let you take away those common questions.
Thanks, Jamie. Thank you, Chris. So just to kind of clean up a few things that are out there pending in the overall presentation. One of the first things is, do I need a different valve for a steam system? You know, all of our valves are compatible with hot water or steam. You know, the exception is that VO243, which was for the single steam pipe that worked through the air vent on the radiators. What do the numbers on the actuator mean? Do they relate to the certain temperatures? You know, Chris touched on this and gave a pretty good explanation. You know, the big thing about these is that typically that 1 to 6 is going to range from about 43 degrees to about 82. And 3 being that center road of 70 degrees that we're all used to having rooms set at. You need to reference the individual guide that comes with whatever actuator you're using, just to be sure on that, so that you can find the right comfort range for your customers. Can I install your actuator on a different valve that's already been installed? Yes, but you need to double check that. You know, we've got capacity to put actuators on a lot of other manufacturers, you know, American Steam, Taco, Danfoss, Amok, and Macon. But, you know, the high capacity is a little bit different, and it's got a much larger connection, as Chris pointed out. So take some time, do your research to make sure that it's going to meet your needs and your customers' requirements. What consideration needs to be taken into account if changing from steam to hot water? You know, Chris just touched on this, on the capacity of what the radiators are capable of doing. Something else to keep in mind is, do I have single pipe or dual pipe? You know, what sizing's in it under the crawl space or under the ground that's feeding these pipes? It's real important to understand that part of the design criteria, just to make sure that, you know, we're going to be able to have the capacity and the volume that we need to keep our customers comfortable. Can the radiator valves be serviced? You know, Chris did a real good job of showing our cartridge serviceability on those. It's one of those features that I think it's really important to be able to know that, a few years down the road, you're going to be able to get parts and you've got a radiator valve that has been in place for many, many years. And it's going to consistently give you that serviceability so that people aren't having to, do a change out every few years to something different. Does the orientation of the actuator matter, vertical or horizontal? Chris pointed out that depending on your application and whether you're in a cabinet, whether you need to have remote sensing, it's critical because right around the valve, we see a very different environment than we do outside the cabinet or a few inches away. So, when we are doing those applications, it's critical to sit there and look and say, if I'm direct sensing, I want to be on the horizontal. If I'm going to remote sense, I can put it on the vertical because it's going to see a very different environment and maintain the comfort for the customers.
Thanks, Mike. And then we've got a few questions that have come in live. So if you have any questions here at the end, keep throwing them into your Q&A. We're going to start answering these in the order in which they've come in. So I believe the first question we've got is, what is the battery life length on the HR90? So that's our digital programmable actuator. And to answer that question, in lab conditions, because battery life is very dependent on a lot of different things, but in lab conditions, you should get roughly 2-year life out of the HR90. It does have low battery warnings, so it'll let you know, but we always try to strive to get several years out of our batteries. So lab conditions get you to 2 years under that one. I've got a question here on a mixing. Oh, let me take this one in order. So to be clear, none of these devices are actually telling the heating equipment to produce heat like a thermostat. In theory, they are only managing temps when the main heating system is in operation. So yes, to clarify that, you're 100% right. What most of the industry is used to, at least in North America, I should say, it's a little different in Europe, but in North America, usually what we see is digital thermostats that, thermostat calls for heat, it opens a valve, and then by way of an in switch, we tell that valve to tell our pumps and boiler to come on. When you're looking at the non-electric actuators, thermostatic or electronic or hell, even manual, there's nothing there that goes back to the boiler. So as I've shown, I think I showed this slide after the question came in, but there's nothing there to tell it to come on. So usually we still go back to a central thermostat to kick the system on. And then what's going to happen is every radiator is then going to open or close as needed, but we kind of have to have that one thermostat set. And what I've seen a lot of people do is they'll actually set that thermostat a little warmer than comfortable. So let's say you want the house to be at 70 degrees. They may set that thermostat at 72. Just in case there's one room that's a little cooler, it will actually still tell the system to come on and it'll have heat available when that opens. I've got another question on the mixing application. Does the flow rate stay the same on the mixed side? It's going to depend on how your system's plumbed. So I'm going to give my favorite answer. It depends. it could, but it could also vary. So whoever had that question, if you can give me a specific example, I could probably dial that in a little bit, but there's a few too many variables to answer that. The common one is if it's just one temperature that you're mixing and that's the only thing happening in the system, then yeah, your flow rate's going to be the same. But we see a lot of mixing on 2 temperature systems and doing other things. So it depends. That'll be my favorite answer for that one. Mixing valve and circulator has backflow protection. We ship the circulators with built-in check valves that will give you backflow protection. The mixing valve, it depends on what you're looking at. Some of our thermostatic mixing valves have them, some do not. It's going to depend on the configuration. But the circulators, we ship them loose in a box. Most people throw them in. And then I've got, you show valves on convectors. In my area, most cast iron units have supply and return coming from the floor. Will this make a difference? No, not really. As long as you have room to cut a valve in, you can make that happen. So as I showed in some of those selection images, the one thing you want to keep in mind is you don't want to install the actuator vertically. So if you get into a spot where, let's say, it comes up from the floor and then shoots over directly 90-degree into the radiator, if it's on the floor where you don't want an actuator, you could always run it up the wall and do a wall-mounted actuator instead. And I think we are running out of time, so I want to, there's a couple other questions I'll try and get to before this ends, but I will pass this back over to Jamie for some final notes.
That sounds great. Thanks, Chris. We've got a couple minutes left here. If you want to answer the last couple of questions, we can absolutely do that.
So one of the questions was, what kind of battery does the HR take? They're standard 1.5 AA type LR6. I think that was the last question we had out there.
Wonderful. Great. Well, we'll take a minute and wrap up here. Thanks again to Chris for providing us with the technical overview today, and thanks to Mike for helping to answer some of those questions. Today's training is the last Resideo customer webinar for 2020. We've really enjoyed providing these trainings over the last several months, and we're excited to announce that in 2021, we are going to continue offering this Resideo customer webinar series going forward. We're going to be offering these webinars twice a month in the new year. We will be sending out an email communication with the details of our next sessions, and we'll be posting the schedule shortly on the website that you see on the screen. So stay tuned for that information. In the meantime, make sure that you visit resideo.com/webinars, and by clicking on that webinar recordings tab, you can find recorded versions of our previous trainings that you can refer back to. And then one last reminder for our contractors who did not include your NATE ID on your registration form and you would like credit for today's session, make sure you send an email with your first name, your last name, your NATE ID number to homes.university@resideo.com within 1 week of today's live webinar in order to receive credit for attending today's session. And then 2 final things to note as our session ends today. You are going to be prompted to complete a survey regarding the webinar session today. Please take a few moments to provide us with your feedback on the training that you participated in today. We are very interested in your feedback on today's session, and we do use all of your feedback to help us create future training. So your feedback is very important. And finally, you're going to receive an email from us in just a few days that includes some follow-up information on the hydronic products that we reviewed today, as well as a link to the website for more information on our future webinars as well. Thank you all for joining us for today's Resideo webinar session. Have a great day, everyone.